Let's now look at annuities with non-annual cash flows, which are very common. Think about mortgage payments, which are monthly. Think about paychecks. So we have to figure out a way to find the future value and present value of these annuities, regular payments, regular intervals. However, the intervals are not necessarily annual. So what do we do if the cash flows are not annual? We do something very similar to what we did with time value of money of single cash flows, future value and present value of single cash flows. Remember that we had this two-step adjustment that involved M. There, M was the frequency of compounding. Here, M is going to be the frequency of cash flows. So for example, if you have two cash flows per year, so semi-annual cash flows, M is 2. Quarterly cash flows, M is 4. Weekly cash flows, M is 52, so on. We do the same two-step adjustment to our formulas. So we take our formula, in this case annuity formulas, and we divide all i's by M, and in this case we're going to have more than one I. So that's one difference with the single cash flows before. So you have to make sure you do not forget any of the i's. And that will give us the periodic rate, either the periodic interest rate, growth rate, or the periodic discount rate. Then we will multiply all n's in our formulas by M, which will give us n times M, n being number of years. M is cash flows per year. So in our formulas, n times M is going to be the number of cash flows, the total number of cash flows. So this is what our formulas will look like. The future value of annuity equals CF times, we have this term. In that term, we have two i's, one in the numerator, one in the denominator, and they both have to be divided by M. And then we have this one n as a power term in the numerator, and that needs to be multiplied by M. Present value, there we have three i's in the present value of annuity formula, so all three have to be divided by M, and the one n in the denominator of the second term have to be multiplied by M. Let's look at an example. Suppose you invest $1,000 each month. So right away, that underline each month tells us two very important things about this question. 1,000 each month means we are in the annuity world. This is not single cash flow. So we will have to use annuity formulas. And month means M is 12. So we have to use the versions of the annuity formulas with M in them. So for 7 years, that's going to be our N. So each month, 7 years, 7 times 12. So we're going to have 84 of these cash flows, $1,000. And earn an interest rate of 1.7%. Remember, when it's not specified, it's got to be annual. So this is our I, which we will have to divide by 12 to find the monthly rate. So the big question is, what is this question asking us? How much will you have total in 7 years? Okay, so this is a classic future value problem where we are depositing, in this case, annuity-like cash flows, and we are trying to find out what will be the balance at the end after all the cash flows. Since we are looking for the value after cash flows, this is a future value question. So this is a future value of annuity with monthly cash flows. So we now zeroed in on the correct formula. FV annuity with i's divided by M and n multiplied by M. So this is our formula. So we can plug in the correct values, right? Everywhere you see I, which is in two places, we put 0.017. We divide both of those by 12, and then we multiply 7n by M to find the total number of cash flows, which is 84, and that's the power term. Let me now show you how to do this in the calculator. I will start with the term in the parentheses, which here is in the numerator. So I will do 0.017 divided by 12, which is the monthly interest rate. And since our cash flows are monthly, we need the interest rate to be also compounded monthly. Since I will need this number twice, one in the numerator, once in the denominator, I will store this STO1 in the calculator so I can recall it later when I need it in the denominator. Now, continuing with the numerator, I will add 1 to this and raise it to 7 times 12 minus 1, and this is our numerator. Now, divided by, I had already computed the periodic rate, so I need to now recall 1, our CL1, equals 89.135342. Let's again think about what is this 89. We are multiplying each cash flow by 89 to find the future value. Each cash flow is 1,000. If you look at the question, we actually have 84 of these. But instead of multiplying 1,000 with 84 cash flow, because of compound interest, we are earning interest, right? Instead of 84, we are actually multiplying by 89. And the difference is the interest we are earning per dollar. For each dollar of cash flow, monthly cash flow, the future value would have been 89.135. How about 1,000? Well, let's multiply this by 1,000 to find our final balance. So at the end of year 7, after these 84 monthly cash flows, we would have 89,000 something in that bank account. Now, let's take this question one step further. How much total interest in dollar terms did we earn? We will approach it the same way we approached previous problems, where it's a matter of the difference between how much you have in the account, so the balance, minus how much you put in. Now we got to be a little bit careful. We know the balance, this is FV annuity, minus how much are we putting in? We are putting in $1,000 for 7 years, 12 times a year. So what we need to subtract is 1,000 times 12, sorry, times 7 times 12. So we are putting in 84,000, right? So 89,135 minus 84,000 is we will have earned an interest of $5,135.34 interest in dollar terms. Let's look at another question. Suppose you are going to receive $500 weekly, and right away this again tells us cash flows weekly means this is annuity, regular payments. It's non-annual, so our M is going to be 52, right? For the next 4 years, this is going to be our N. How much is this cash flow stream worth to you today? All right, so this tells us we are looking for a value that precedes all the cash flows. So we are looking for the present value of this monthly annuity. Okay, assume a discount rate of 9%. So here, because we are doing discounting, finding present value, I is called discount rate, and I is 9%, and that's annual. So we are going to have to divide this by 52 to find the weekly discount rate. Right? So we are looking for the present value of annuity. We need to do our two-step adjustment to the present value formula. Divide the 3 i's by m, multiply the n by m, and then let's plug in values. CF is 500, each cash flow. Then the term, there are 2 terms inside the parentheses. The first one is 1 divided by I over m. So we plug in 9%, 0.09 for I and 52 for m, minus 1 over, again, I over m times 1 plus I over m raised to 4 times 52, n times m. Right? So 4 times 52, that means that's 208 weekly cash flows of $500 is what we are expecting to receive. So what is the value? How much would we be willing to pay for this thing that will generate these cash flows for us? So let me show you again how to figure this out in calculator. This can get a little bit complicated. Once again, I'm going to start with I over m because this will show up 3 times in the formula. So let's get that out of the way. 0.09 divided by 52. That's my weekly discount rate. Store 1. So I stored it in the calculator so I can recall it 2 more times later on. Let me add 1. I'm working on the denominator of the second term here, the power term. Let's me first get rid of that, right? So 1 plus I over m raised to, open parentheses, 4 times 52, close, 1.43 something. I need to multiply this by I over m. So multiply it by, recall 1. That's our I over m, which I had stored earlier. 0.002480. Now this is in the denominator. A 1 over this, I can just press on this 1 over x, and I get the second term, which is 403.227334. Okay, so that's the second term inside the brackets in this formula. Now I don't want to lose this, and I don't want to copy this down because I don't want to make a rounding error. So what I'm going to do is I'm going to also store this because I need to recall it later. I already stored one number, so this has to be my STO2. Okay, so let me now go work on the first one, 1 over I over m. I already have I over m, recall 1 over x, reciprocal. So this is the first term. This minus the second term, which is recall RCL2, and the difference is 174.55. I'm going to multiply that by 500. Okay, now let's compare this to how many total cash flows we have. So the total amount is 500 times 52 per year and 4 years. So that's 208. So we have 208 cash flows. And here we are multiplying our cash flow of 500 not by 208, but by 174.55. Why? Because we are discounting, right? Each dollar in the future is worth less than $1 in present value terms. And this term is capturing that. Instead of 208 of these cash flows, the value is driven by 174.55 of these cash flows because each dollar is worth less than $1 today. All right. So then we need to multiply this by 500, and this gives us the present value of this asset that is expected to generate these cash flow. That means you'll be willing to pay a little more than $87,000 for something, for an asset, for a financial security or something like that, that is expected to generate $500 every week for 4 years if your discount rate is 9%. Remember from earlier discussion and an earlier video that this discount rate captures your required return, right? Given the riskiness and all the time value of money, inflation, earning power, and interest rates, opportunity cost, all that stuff. If you need this asset to generate 9% return for you on an annualized basis, you would not want to pay more than $87,000 for this. If you pay exactly this amount, your expected return from this investment would be exactly your discount rate, 9%. Now, if this is not enough, if you actually require a higher return, we would pay less for this. Present value would be lower. If we are okay with a lower discount rate than this, 8%, 7%, that would increase the value, present value of these cash flows. Okay, so that's the relationship.